Dear students, today we'll discuss about pushdown automata. So, the mainly earlier we discussed about finite automata. So, finite automata is a diagram which is used to solve the compiler designing problems. But when it comes to finite automata, here we don't have any memory concept. Means we can solve a certain type of problems, but some problems are there where they require some memory. For example, I want to solve the problem like the language which contains a to the power of n and b to the power of n. Means the number of a's should be equal to number of b's. For example, the language should accept the string which contains some 4a's and 4b's. If 3a's and 3b's also, like that. So you're not supposed to take n number of a's and m number of b's. So you should take equal number of a's and b's. In that situation, it is not possible to implement with the help of finite automata. So that's why we are preferring pushdown automata. Why? The only the reason is it contains memory. So now we discuss about informal introduction of pushdown automata. So here we are having one advantage to choose pushdown automata is a stack. Stack already we know that it is one type of memory. So pushdown automata is using stack to store the content. Okay. So and we know that stack is following last in first out way. So whatever the content you stored on stack means push operation. If you do any push operation, pop will be done last in first out. The element which is inserted last into a stack will pop that item only. Okay. And the pushdown automata is recognizing the context-free languages. So in previous classes, earlier classes, we discussed about context-free languages. And the pushdown automata will be represented one diagram, and the diagram contains a finite state control and input output stack. So we'll show the diagram. This is the informal representation of a stack, sorry, a finite automata. It contains one input tape. Here it will read the input, and finite controller is there. This finite controller takes the input from the input tape, and it will provide the output. Either it may reach accept or reject state. If it reached accept state, we say that the string is valid. If it reached reject state, we say that string is not valid. And in pushdown automata, whatever the input we received, it will be stored under stack. Okay, it will store under stack, and whenever it required, it will pop. Okay, so this is general diagram of pushdown automata. Here what is doing is we are having a finite state control. It reads the inputs one symbol at a time. So finite state control is there. This is finite state control. It reads single input from the input tape. Once it is processed, then it go for another input. Like that it will take. So it consumes from the input the symbol that it uses in the transition. If epsilon is used for input, then there is no input symbol is consumed. Okay, so every input symbol it will consumes. It means it will take from input tape, and it will store it into stack. And the retrieved string, if it is epsilon, then there is no any process, and it goes to the new state, which may or may not be the same as the previous state. So when you consider a diagram, so it will move to the next state. So for every input, it moves to the next state. So generally in finite automata, it's happening like that only. So for example, assume it we're having some Q1 state and Q2 state, Q3 state like that. So if I took input A from Q1 state, it moves to Q2 state. So if I took input B from Q2 state, it moves to Q3 state like that. So for every input, whatever we are having, it moves to the next state like finite automata, in pushdown automata also, and replaces the symbol at the top of the stack by any string. Earlier we discussed that whatever input we received through input tape, it will store it into stack. So replaces the symbol at the top of the stack by any string. So the string could be epsilon, which corresponds to pop of the stack. So once you retrieved any input symbol, if it is having different from the stack, then it will pop operation will do. Otherwise push operation will do. So it could be the same symbol that appeared at the top of the stack previously. That is, no changes to the stack is made. So if we received the same symbol, then stack operations will not made. So it could also replace the top of the stack symbol by one other symbol which is fx changes the top of the stack but does not push or pop it. So if it finds any different symbol, so it will change the top of the symbol, means modifications will done. Finally, the top stack symbol could be replaced by two or more symbols. So it may be replaced with more than one symbol, which has the effect of changing the two stack symbols and then pushing one or more new symbols onto the stack. So simply assume it, I want to find out the language which is having some a to the power of n, b to the power of n. Assume it some n equal to 4, means it will generally what will happen is, assume it we are having some a. Just a minute. Okay, next one is b. So input it reads from here. First it will read a, then we'll push it into stack. Next it will read another a, we push. Next it will read another a, we push. Next it will read another a, push operation. So if the same symbol is coming from the previous symbol, then push operation will do. If it is not having same symbol, then pop operation will do. So b is getting, it is different symbol, so pop operation will do. Another b we are getting, so pop operation will do. Another b we are getting, so pop operation will do. Another b we are getting, so pop operation will do. And finally every string terminated with some symbol. So if it received that symbol, then it will check whether still any more string is there. Again it will check whether any more elements in stack. If both are empty, then accept state will occur, otherwise reject. Assume it if I am having another more b. So then it checks whether stack symbol is there. No, then push operation will do, means b will be here, but the string is empty. Next string is we don't have, but still stack elements are there, means we don't have equal number of a's and b's, then reject state will occur. Okay, hope you understand. Again I will repeat that. It checks equality. Generally we go with equality. So it will push elements and it will pop the elements. If I assume that a to the power of n, b to the power of n, so this is the language which accepts this pushdown automata. So I gave 4 a's, 4 b's. So whatever the a's I received, the same symbol, whenever you are receiving the same symbol, it will keep it on stack. If whenever you are receiving different symbol on stack, then pop operation will do. So 4 pushes are done and 4 pop operations are done. So finally string is over and stack is also empty. So it will take accept state. Assume it if I took 4 a's and 5 b's. So finally when I inserted 4 a's, 4 push operations will done. When I go with 4 b's, pop operations will done. When I'm trying to another b, but stack is empty, so it will insert into stack. But finally string is empty, so dollar symbol like that will mention. So finally the string is completed, but still stack elements are there, means both are not equal, then reject state will come. This is general happening of pushdown automata, and this is informal representation of pushdown automata. Now we go through with the definition of pushdown automata. So the formal definition of pushdown automata is similar to the finite automata. Means in finite automata we are having four symbols like sigma, delta, okay, starting symbol and set of final symbols. Same like that here also. But here additionally we are having stack symbol. So the stack is a device containing symbols drawn from some alphabet. So whatever the input you provided, that from that input it will be stored into the stack. So the machine may use different alphabets for its input and its stack. So now we specify both an input alphabet. Generally input is represented with sigma and stack is represented with tau symbol of t. We call it as a of t. So the formal notation of the pushdown automata will mention p equal to q comma sigma comma tau comma delta comma q naught comma z naught comma f, where q is a set of states, sigma is a input symbol. Okay, so this of t is a stack alphabet. So this component, which has no finite automaton analog, is the set of symbols that we are allowed to push onto the stack. So whatever the input symbols we are allowing, that will be pushed into the stack. So stack is contains input symbols, delta. So it is a transition function. So as for a finite automaton, delta governs the behavior of the automation. Formally, delta takes an argument as a triple. So it contains three arguments, where q is the state in the queue, means at present where we are having, on which state we are having. A is either an input symbol in sigma, or a equal to epsilon. So it may be a null string or it may be some symbol, means the input symbol which we are having. Okay, and x is the stack symbol, that is a member of tau. So now what is the stack symbol we are having? So it will get it from stack. It will not pop, just it will get it from stack. Okay, for the comparison purpose. This is about delta. Q naught, it is a starting state. So like a finite automata, pushdown automata is also having starting state. Z naught, it is the starting symbol of stack. So stack, if it is empty, then Z naught will be there. F is a set of accepting states, so we may call it as a final states also. For example, so pushdown automata will be used like this for this type of languages. Some LW, WR equal to W, W to the power of R, where W is in 0 plus 1 whole star, means W is the combination of zeros and ones. So here the language is nothing but should contain the language of input string and the reverse of the string, both should be there. Like for example 110, then 011. So this is W and this is WR. This is W and this is WR. So like this type of languages we can implement with the help of pushdown automata. Now we discuss about the graphical notation of pushdown automata. So finite automata is represented graphically and tabular representation also. Like that, graphical notation for pushdown automata will be there. So here the transition diagram, which is having the nodes, corresponds to the states of the PDA. So as usual, like finite automata, here also we are having states, we call it as a nodes, and the arrow is the label start, indicates the start state, and doubly circled states are accepting as per finite automata. So arrow mark with start, it indicates the starting state, and double circled arcs call it as a accepting states or final states. The arc corresponding to transitions of the PDA in the following sense: an arc labeled with x/alpha from state Q to state P means that delta of Q comma A comma X, the transition function Q comma A comma X. So A is an input, X is a stack symbol, Q is the next state which you are going. So containing the pair of P comma alpha, perhaps among other pairs. That is, the arc labeled tells what input is used and also gives the old and new tops of the stack. So Q is nothing but the next state which you are moving, A is nothing but the input symbol, X is nothing but the top of the stack symbol. What is the stack symbol we contain? So here this is the diagrammatical representation of Pushdown Automata. So generally we design this is for W to the power of R. Okay. So in next classes we discuss about how we are going to design PDA and everything. Assume it here we said that Q comma A comma X. So in this state Q naught is a state, it's a self loop is there. For this it contains for zero input, Z naught is a stack symbol and stack will contain 0 comma 0 Z naught. So input is 0. Here Z naught is the stack symbol, current stack symbol. If stack is empty, it will be represented with Z naught. Next 0 Z naught means 0 will be stored into stack. So if it contains 1, Z naught is a starting symbol. Assume it if Z naught is starting symbol, then 1 will be fed. Means either in both only 1 will happen. Okay. If it is a stack is empty, if you start with 0, then 0 will be there. If you start with 1, 1 will be there. So that is based on the input which we are having. For example, if I contain some like that 1 1 0 0 1 1. So stack we have starting with 1. I started. So 1 is input. Then Z naught stack is Z naught. So Z naught will be there, means empty. So 1 will be pushed. Next 1 is there. So 1 stack symbol is also 1. Then 1 what will do? 1 1. So again push will do. Next input is 0. So if 0 is input and top of the stack is 1, then 0 1. So 0 will be pushed. Generally, to divide the things, we go with epsilon symbol. So when you are moving with epsilon to the next state, checks whether the top of the symbol is 0. Then what will do? 0 will be 0 will be the next one. So next input symbol, it checks, it goes to the next state Q naught. Again it checks with 0 or 1. So if 0 is there, then 0 will be placed and we are pushing epsilon. So if 1 is there, 1 will take, we are pushing epsilon. Means just we are receiving, we are popping. This indicates pop operation. So 0, same 0 will be there. Means we are not doing anything. Here observe that earlier we have two operations. This indicates stack existing and next one is we are going to push. But here we are not pushing. Okay. So 0 just will keeping 0. Here we are taking, if it is 0 means input is 0, just we are popping with 0. Next we are reading 1. If it is 1, just we are popping 1. Next we are reading 1. If it is 1, just we are popping 1. Okay, so all popped. Next input we don't have, will consider as epsilon. If stack element is Z0, finally we got Z0 only, then Z0 will be there and we reached Q2. Hope you understood what is pushdown automata. So simply we are designed for input output of WWR. Once I am repeating the thing, assume we are having 110, 011. So here these are the possible inputs. It indicates here this is the input which we received, and this is the stack symbol, present symbol. So what will happen? This will push into stack, and this is the symbol, means existing symbol. So initially we got 1. So 1 is there, then if Z0 is input symbol, stack symbol, then 1 will be pushed. Again 1 is there. So 1 is there. If stack symbol is 1, then 1 will be pushed. Again we read 0. 0 is there and stack input is 1, then 0 will be pushed. So 110 is on stack. 110 is on stack. So this is W and will include epsilon. If epsilon move is there, so whatever the stack element will keep same. Okay, just we are moving to next state. Now what will happen if input 0 is there? So this is 0. 0 is there, then same 0 will pop. Okay, and epsilon move. Just we process the epsilon move, that's all. Okay. Next we'll read 1. Nothing is pushing. Next we read 1. 1 is read, so stack element is 1. Then just we are not doing anything, just pop operation is there. Next one is 1. 1 is there, so if stack symbol is also 1, just we are popping. This is, it indicates pop. Next Z0. So Z0 is there, and input we don't have. Input we have epsilon. So epsilon is there, and stack symbol is Z0. Stack symbol is Z0. Just Z0 will be there. We are not pushing anything, and we are reaching to Q2. So this is about the graphical representation of pushdown automata. In next class, we discussed about how we are going to implement pushdown automata and these all things. Thank you.